thoughts I just cannot repress. Intuition.
Hi, we are a group of 3 guys and we hope you will appreciate our video. It will be about installing a needed local environment, to use some computing tools with Spark from Apache, using a grid tool from Gensim for deep learning on a massive dataset, and finally compare efficiency between a basic computing and a computing which is speeding up the process. So basically we decided to make our project about Word2Vec from Gensim. First we will be installing Spark in our local machine. In this course we use the virtual machine, but we have the tools to do it on our local one. Then we will create our model using Gensim and its parallelization tool. After that we will train on our model on Gensim. And finally we will create clusters representing words within their context using Spark. So according to Wikipedia, Gensim is an open-source vector space modeling and topping modeling toolkit implemented in the Python programming language. And Word2Vec is a deep learning tool from Gensim which allows us basically to reconstruct linguistic context of words within a corpus of text. Many of you may have heard about deep learning. Google published Word2Vec algorithm, and after trying it, you can ask questions such as Copenhagen is to Denmark as Paris is to France, or have a geometrically way for requests such as king minus man plus women, and it should output queen. And another example would be ask for a word which doesn't match, as man, woman, child, tree, and daughter, and it should be return tree. So first of all, before training our dataset, we need to install Spark on our local machine, because we will use it for clustering in the end of the project. And if we don't do that, the computing will be very slow, because we will see that compared to sklearn for k-mean clustering, it is much more faster with Spark. So installing Spark on our machine is not hard, but it takes a little time to do it. First we go to the Spark page, we click download, we take the last version, and then we download Spark. Okay, we use first one. Good. So once it's downloaded, of course we read the README and we see that to build Spark, we have to tap these things. It should take some time to be installed, and once the paths are set up, you will just have to ask for this, and it will open up a notebook IPython, and all should work well. Well, now let's talk about what we concretely did. We processed deep learning with Word2Vec on a dataset of 100,000 movie reviews. We have labeled and unlabeled ones, but it won't matter because Word2Vec only need raw paragraphs as input. First, we loaded the data thanks to the Python library pandas. We opened the TSV file. T is just here for tab instead of comma in the C of CSV, and SV are separated files. Once we load the data, we verify we didn't miss any review. Real text always to be cleaned up. We import beautiful soup, which will help us to get the text from the TSV file. We also import regular expression and a list of stop words. What we do with that? We make a function to convert a document into a sequence of words. It will return a list of words. First, we remove all HTML notations. We also remove non-letters, we'll split our text and lowercase it. We remove stop words and we return our list of words. Then we have to keep the fact that words are in a sentence in our data, because Word2Vec extracts the context of a word within its sentence. Return a list of sentences, where each sentence is a list of words. Finally, we compute those two functions on our data. And we make some tests to see what we just did. And we make some tests to see what we just did. Now, let's use Word2Vec on it. First, we will have a little speech about how computing with Word2Vec.
Training the Word2Vec model is time-consuming. Now, we will show how to improve the process using multi-processing. For one thread, Gensim splits the documents in chunks of sentences. Then, the model is trained on each chunk of documents sequentially. Thanks to this implementation, the model can be trained on a stream of documents. The Word2Vec model can be trained continuously. For example, the model can be trained on a stream of news. However, here, everything happens in a unique process and it is very time-consuming. The Gensim implementation contains several ports. It means we can train the model from several inputs at the same time. So, we split the corpus into several jobs of a fixed amount of sentences. Then, we can define multiple processes and we can assign jobs to these processes. Thanks to this, the Word2Vec model is trained simultaneously through the different ports. Using multi-processing enables to reduce strongly the computation time. Indeed, the same work is now done in parallel whereas it was done sequentially. Using 2 threads enable us to gain a 1.75 times speed improvement. Using 4 threads gives 2.85 times speed improvement. The Word2Vec model doesn't use more memory when we use several threads. So, using the multi-processing abilities of the Gensim implementation of the Word2Vec model leads to huge speed up.
Good. Now, let's train Word2Vec on our data. First, we set values for the parameters following, such as 300 will be the word vector dimensionality, so typically it will be 300 features. 40 will be the minimum word count. We'll use 4 threads to run in parallel. 10 is the context window size, and we also set the downsample setting for frequent words. Of course, we import Word2Vec, and we train our model on the data we cleaned previously. It took the computer 20 minutes with 4 threads running in parallel. Finally, we save it, and we do some tests. Now we have our Word2Vec model. We process clustering both with sklearn and Spark. We will see that Spark computing is good for big data processing. First, the same way we introduce Word2Vec computing, let's have a talk about k-mean clustering with Spark and its algorithm.
So let's dive into how the k-means clustering algorithm is working. By initializing our PySpark clustering algorithm, we're feeding it our dataset, and we're choosing the number of desired clusters, and choosing max iterations, and how many times it's going to run, and how it will initialize. That means the initialization mode will be set to random. So to explain how this works, we have 4 steps visualized in these pictures, and in step 1 we can see that there are three dots: the red, the blue, and green. These are randomly generated points, which will be the start out centroids, which will say where our clusters are starting out. And when we have these, it will take the closest points and like cluster them together. And if we go to step 3, we can see that the centroid is actually moving towards the mean distance between all the data points. So now we have a new kind of centroid, and this will this will end up like with new data points in each cluster. As you can see in the step 4, some of the data points are changing colors, which will imply that they are now in another cluster than they were before. And this procedure will run for as many times as you want to, and you can tell that to the algorithm before you run the program. So that's basically how the algorithm works.
Okay, now we want to see the results. It speeds up the clustering and reduces the time of computing by half of it. Moreover, we made 30 runs. It is the number of times the k-means algorithm will be run with different centroid seeds. The default value for Escalon was 10, so we are even more accurate with Spark. Here we can see, thanks to htop request in the shell, what was happening during the clustering. We used the 4 cores for almost 100% of them, and as a matter of fact, we went close to 400% regarding the CPU. So finally, let's have a look at our results. Here are 3 of the most impressive results we got. We printed top 10 clusters. Obviously, the first one is about empathy. Second one are names, and the last one are adjectives, exceptional, incredible, astonishing. Well, I hope you guys enjoyed. We really enjoyed using Gensim combined with Spark, which both showed us parallel computing is a splendid tool for computing big data. Thank you for watching.